AB Calculus Note Card 59, Integrating the Natural Logarithm Function. This is the 59th video lesson in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District, who developed the Note Card system. The graph of y equals ln x is shown in the coordinate plane to the right. And let's just go ahead and be sure we understand what this is. This ln is the natural log, or log base e, of x. So the properties of y equals ln x are, and this is a big one right here, the ln, or natural log of 1, equals 0, and that is because e to the power of 0 equals 1. And that's what a logarithm is. It's what power do you raise the base to equal what you're taking the logarithm of. Okay, and then we have these three main properties of logarithms. The product property first, then the power property, and finally the difference property. And now we come to this last line. The integral of 1 over x dx equals the natural log of the absolute value of x. And what this is 1 over x is x to the negative 1 power. And if we use our power rule and we take x to the negative 1 plus 1, we get x to the 0 power. And now this is the crucial thing, we're dividing by 0 using the power rule plus our constant integration. And when you divide by 0, that is going to be undefined. So therefore, the power rule in this single instance does not apply. And so here we have the natural logarithm function. If you go back to the note card lesson on the integral or derivative of ln x, you're going to see this 1 over x. Now, this one on the left, 1 over x dx, integral of 1 over x dx, you get the natural logarithm of the absolute value of x plus c. But for this one, the 1 over u, this is for when you have the composition. In other words, something not just x, and not even just something times x. There has to be something else. So we're going to go into this now. We are going to really have a hard time doing this before we got to use substitution a couple lessons ago. So let's go over some problems. We have the integral of x minus 4 over x squared. And so the way to do this is this x squared serves as a common denominator to both the terms on top. So my preferred way to do this is to simply split these terms on the top. So we get the integral of x over x squared dx, and then we have minus the integral of 4 over x squared dx. Hope you can see that. And then continuing to simplify to the right, the integral of x over x squared simplifies to integral of 1 over x dx. And then we continue, we have, I'm going to bring this 4 outside, 4 integral of 1, and this x squared down here, what that becomes up here is x to the negative 2 power. And then continuing to the right, we have the integral of 1 over x dx is the natural logarithm of the absolute value of x, and then we're going to have minus 4, and we're going to have x to the power of negative 2 plus 1 is going to be negative 1, and we divide by the power we raised 2, which is negative 1, plus c. And now, working below, we still have natural logarithm of the absolute value of x, and then this negative 4 divided by negative 1 simplifies to positive 4, and then this x to the negative 1 power, the x to the first power comes down here in the denominator. Then we have plus our constant integration c, and this is going to be our answer, our integration. Okay, let's go to the next problem. We have the integral of 3 e to the x power divided by 1 plus e to the x. And what we should see is we do not have a single common denominator we can work with. So we're going to use a u substitution. So we're going to say let u equal 1 plus e to the power of x. And now taking the derivative of both sides, we get du is equal to e to the power of x dx. So therefore, if we solve for dx, we get dx is equal to du over e to the x power. And so now we can substitute back in. We're going to be able to put in for this u here. And then we're going to be able to substitute in du over e to the x for this dx here. Okay, now in working below, I'm going to take this 3 took it outside, and we're going to have e to the x here, and then 1 plus e to the x power in the denominator we replace with this u, and then we replace this dx with du over e to the x power. And what happens here? Well, we have a cancellation. And so continue to work below, we have 3 integral of 1 over u du. And that brings us back to this thing right here, okay, in the last line. And working now to the right, we have 3 natural logarithm of u plus c. And now we're going to take our 1 plus e to the x power and plug it in right here. And continuing to the right, we have as our final answer 3 natural logarithm of 1, absolute value of 1 plus e to the x power plus our constant integration c. And this is going to be our answer. This is an absolute value bracket here. Okay, next, problem 3. Again, similar to problem 2, this is the integral of 4 over 2 minus x. We're going to let u equal 2 minus x. And differentiating, we have du is equal to negative dx. And so, therefore, dx is going to be equal to negative du. And so now we have what we need to replace. So I'm going to come down here, and we'll have the integral of 4 over u, and we have replacing the dx, replace that with negative du. Yeah, it works to the right now. Okay, what we have here is we can take this negative sign and this 4 out front. So we have negative 4 integral of 1 over u du. And so now we have a easily integral format. So we end up with negative 4 natural logarithm of u plus c. And working below, we're going to take our 2 minus x, replace this u right here. So we get negative 4 natural logarithm of absolute value of quantity 2 minus x plus our constant integration c. And this is going to be our answer. Next, problem 4. Now, one thing that, if you're new to this, you may not be in the habit of is looking at the basic integrand, and if we say let u equal this denominator here, 2 plus x cubed, when we take the derivative of this denominator, is that going to cancel out by division this x squared on top? It will, won't it? So just something to look out for as you set up your u substitutions. Okay, so we're going to have let u equal 2 plus x cubed. And so taking the derivative of both sides, we have du is equal to 3 x squared dx. And solving for dx, we have dx is equal to du over 3x squared. And so we'll be able to replace now this dx. And working below, we have the integral of x squared over u times dx, which we're substituting du, over 3x squared. Right? So we should know that, should see that we have a cancellation of x squared over x squared. So working below, we have this 3 sitting down there in the denominator. So I'm going to just bring 1/3 to the front. And we have the integral of 1 over u du. And this is going to be our natural logarithm. So we have 1/3 natural logarithm of absolute value of u plus c. And finally, we're going to take our original u, replace this u here, and so we have as our final answer 1/3 natural logarithm of 2 plus x cubed plus our constant integration c. And that's going to be our answer. Now, the last problem 5, I worked this out before making this video recording and ran into some roadblocks, and I had to work through what we were substituting. So what we're going to do is take u and replace this x plus 1. We're going to say let u equal x plus 1. And then we have du is equal to dx. So that's going to be a simple substitution here. So let's bring this down. We have the integral of x over 2 u squared, and then we're replacing dx with du. Now, we didn't end up with something that could now cancel this x, did we? But what we're going to do is substitute back this x in terms of u. And so up here, working to the upper right, we're going to have x is equal to u minus 1. And now we're going to take this u minus 1 and substitute in for this x here in the numerator. So that's going to be equal to u minus 1 over 2 u squared du. And working to the right, we're going to take this 2 in the denominator and put that out front. So we have 1/2 the integral of u minus 1 over u squared du. Now, we have a common denominator, this u squared, and we have two different terms in the numerator. So we're going to split up these terms in the numerator. So we get 1/2 the integral of u over u squared du minus 1/2 the integral of 1 over u squared du. And continuing to simplify the right, we have 1/2 this u over u squared, integral of u over u squared simplifies to 1 over u du, and then this next term, this next integral, negative 1/2, we have integral of u to the negative 2 power du. And I'm going to now work below. We're going to have 1/2 the natural logarithm of absolute value of u minus 1/2, and we're going to have u to the power of negative 2 plus 1 is negative 1, and then we're going to divide by what we raised to negative 1 plus our constant integration c. And now we're going to have here 1/2 natural logarithm of u, and then cleaning this up here, we have negative 1/2 divided by negative 1 is going to end up being plus. We have 1, and we have this 2 down here. 2 u to the negative 1 power becomes u down in the denominator plus c. And now we're going to take this value of u here, x plus 1, and substitute it in for this u here, and also for this u over here. in this term. So we end up with 1/2 the absolute value of x plus 1 plus 1 over 2, and we have x plus 1 in place of u plus c. And we could simplify, we could expand this denominator here in the right term, but this is going to be it. A lot of U substitution here. I hope this has been helpful to you. Good luck, and thanks for viewing.